Usually when we talk about a map, there is this, comforting expectation of absolute precision.
Oh, for sure.
Yeah, like you pull up a navigation app on your phone, you see the little blue dot, and you see the grid of streets around you.
Right.
And it's clean, it's perfect, and it just gives you this feeling that it represents exactly what is happening in the world everywhere right at this very second.
Yeah, it gives you the illusion of a fixed, reliable reality.
Hmm.
You just assume that if a car is shown 3 blocks away, it is physically there at the exact same instant you're looking at your screen.
Exactly. But then you step into the world of theoretical physics, specifically like the reality of how physical information actually travels through space, and suddenly that perfect map starts to glitch out.
It really does. The little blue dot is basically lying to you.
Right. We are looking at a landscape of reality that is honestly just completely murky, and today's stack of sources takes that murky reality and completely flips it on its head.
It's a really wild perspective.
It is. We have a highly conceptual collection of translated blog posts, some incredibly deep AI chat transcripts featuring Claude and Gemini and ChatGPT, and detailed conceptual diagrams from a thinker known online as Zionachat or Zionod 2023.
Yeah. And the mission of this deep dive today is to unpack this radical reimagining of Einstein's special relativity.
Which is, that's a massive swing, right?
It's huge. These sources are proposing that the standard diagrams physicists have used for a century to understand space and time are actually hiding the true nature of reality.
Wow.
Yeah. They offer a wildly different model, one that borrows concepts directly from, like, artificial intelligence and deep learning to explain how the universe functions under the hood.
So if you have ever felt like high-level physics relies on way too many abstract, perfect assumptions, this is where it gets incredibly compelling for you.
Absolutely.
We are going to look at the universe not from a perfect, instantaneous, God's eye view, but from the perspective of a neural network trying to piece together a reality that is suffering from severe, unavoidable lag.
And what makes this so fascinating to me is that the author isn't trying to say the underlying math of Einstein's relativity is wrong.
Right, because the math works.
Exactly, the math clearly works. The critique here is that Einstein used a mathematical, clever rationalization to hide the messy, delayed nature of physical information.
So he just sort of patched over it.
Yeah, he made the math work by bending space and time on paper, rather than explicitly dealing with the physical delay of the signals themselves.
Okay, so to really grasp what the author is attacking here, we have to look at how physicists currently map the universe.
Right.
The author takes dead aim at something called the Minkowski space-time diagram. It's the standard grid used to map out events in space and time.
Right, and standard relativity relies on an underlying assumption called Einstein synchronization.
Which is what, exactly?
Well, it's this idea that you can theoretically place perfectly synchronized clocks all over space to form a reliable, perfect grid.
But think about how you would even try to do that in the real world.
You really can't. Say you're standing here and you want to synchronize your watch with a friend who is millions of miles away.
You can't just call them.
Right, because the signal takes time to travel. So you send a flash of light at, say, 12 o'clock. It hits your friend's mirror, bounces back, and reaches you at 12:02.
Okay.
You divide the round trip in half, and you just say, okay, the light hit the mirror at exactly 12:01.
Oh, I see.
Yeah, you build your entire grid of reality based on the assumption that the forward trip and the backward trip took the exact same amount of time.
But the sources label this pre-synchronized grid a pure fantasy.
They do. They call it a ghost of action at a distance.
Those are fighting words in physics.
Oh, absolutely.
Mm-hmm.
They are arguing that assuming this perfect grid exists everywhere all at once is just imaginary.
And the logic there is grounded in pure physical limitation, right?
Exactly. In the real world, an observer can never actually know what is happening right now anywhere else. You only ever receive delayed information.
Right. Whether it is light hitting your eye or gravity pulling on a planet, it all travels at a finite speed limit. There is no instantaneous update.
Exactly. So by assuming a pre-existing synchronized grid, that perfect map you mentioned, Einstein essentially had to mathematically tweak the time and space axes to keep the speed of light constant.
And that is where the famous concepts of time dilation and length contraction come from.
Right. He had to stretch and squeeze the geometry of the grid to make everything fit neatly together.
Wait, let me push back on this for a second. If relativity is so famously successful, like it runs our GPS systems and perfectly predicts planetary orbits, how can the author claim this grid is a fantasy?
It's a fair question.
Is the author really saying Einstein was just wrong?
Well, no, that distinction is exactly the point the author is making. The author sees Einstein's work as a mathematical sleight of hand.
A sleight of hand.
Yeah. The mathematical formulas yield the correct predictions, absolutely. But the explanation behind them treats space-time as a rigid, pre-existing structure.
Like an empty theater stage where events just happen.
Exactly. And the author argues that this is fundamentally backward. Reality isn't a pre-existing stage. It's a delayed, emergent network of events.
Okay, so if Einstein's grid is an illusion masking the lag of light speed, what is actually happening to the data as it travels?
That brings us to the author's proposed solution.
Right, instead of a pre-existing rigid grid, the sources propose the universe actually works like a deep learning neural network.
Which is such a brilliant modern analogy. It processes reality in distinct layers.
Let's break down those layers. The very bottom layer is the input layer, or level 0.
Yeah, you can think of this as countless individual local observers.
The text refers to them as atoms, or a camera eye, or my personal favorite visual troops on the front line.
It's a great visual. Those troops in the front line only know their immediate local now.
Right.
In physics terminology, this is the apex of their past light cone.
Let's translate that for you listening for a second. The apex of the past light cone, imagine standing in the dark with a flashlight, but working in reverse. You only see the light that is shining directly into your eyeball at this exact second. Your eyeball is the apex.
Right.
And everything else is a cone of light stretching back into the past, carrying old news toward you.
That's a perfect way to visualize it. These frontline troops, these atoms, experience an event and emit light. They are sending raw, unprocessed reports out into the void.
They have no concept of the bigger picture at all.
None. So we have trillions of these little frontline troops firing off raw data.
And then we move up to the next layer, the hidden layer, or level 1.
Yes, and this is the author's major novelty here, a concept called the information officer.
I love this concept.
It's so interesting. The information officer is constantly moving through space and time, intercepting these delayed reports from the frontline troops.
Right, but the officer knows that light takes time to travel.
Exactly. If they receive a signal from a star a million light years away and like a signal from the moon a light second away, they can't just assume those events happen simultaneously.
Because they obviously didn't.
Right. They must back calculate the light speed delay to figure out when things actually occurred. They are constructing what the sources call a contour map of simultaneity.
So they are basically acting as a filter.
Yes.
And in an artificial neural network, that is exactly what the hidden layers do. They take raw input data, weigh the variables, filter out the noise, and try to find a pattern before passing it up the chain.
Exactly. And up the chain brings us to the output layer, level 3.
The sources refer to this as the king's room or the emperor.
Yeah. This is where the synthesized, back-calculated reports from multiple information officers are finally compiled into a single public space.
And that compiled public space is what we mistakenly experience as our instantaneous shared reality.
Precisely.
The sources draw an incredible analogy here to video game development, specifically dealing with server lag.
Oh, this analogy is perfect.
It really is. Imagine you are playing a massive multiplayer online game. You have players logging in from Tokyo, London, and New York. Their data takes different amounts of physical time to travel through fiber optic cables to the central server. The game engine, acting as our information officer, has to back-calculate all those disparate pings.
Because if the game engine didn't do that, the game would be totally unplayable.
Exactly.
You would swing a sword, and by the time the signal reached the server, the monster would have already moved.
Right.
So the engine has to compensate for the lag to create a psychological illusion of simultaneous reality for all the players.
So the server generates a post-facto 3D rendering. It stitches together a reality that never actually existed at one single moment in time, but it makes logical sense to the players looking at their screens.
And the author is claiming that this is what space-time actually is.
That is just wild to think about.
It is. It isn't a physical grid. It is the universe's game engine rendering a cohesive reality out of severely lagged data.
It's a massive paradigm shift. You literally stop looking at space as an empty room and start looking at it as an active computation.
Right. But, you know, a metaphor is just a metaphor.
Yeah.
So how does this information officer model hold up when you throw actual hard physics at it?
Good question. The sources put this theory through a brutal stress test in a transcript featuring the AI model Gemini.
Yeah, they tackle a classic problem in electromagnetism.
Yeah.
A magnet and a wire coil.
This thought experiment is brilliant because it forces you to confront the asymmetry of information travel directly.
Right, let's set this up.
Okay, picture a simple number line. We have a magnet sitting on the left side at position -1,
Okay.
and we have a wire coil sitting on the right side at position +1. So they are separated by a fixed distance of 2 units.
Right.
Suddenly, both the magnet and the coil start moving to the right in the exact same direction at 20% the speed of light.
And they maintain that exact distance of 2 between them the entire time.
Exactly. So the fundamental physics question here is, does an induced voltage occur in the coil? Does it spark?
And according to standard classical physics, the answer is a definitive no.
Why is that?
Because they are moving together at the exact same speed, their relative velocity is 0. It is just like two people sitting in the same moving train car. To each other, they are perfectly stationary.
Right. That makes sense.
For a coil to spark, there has to be a changing magnetic flux. Since the magnet isn't moving relative to the coil, the magnetic field isn't changing relative to the coil, so there's no voltage.
Wait, but think about what that means for the lag we just talked about.
Oh, here we go.
If information can only travel at the speed of light, the data here is completely skewed.
Yes, it is.
The magnet and the coil are both moving to the right. The electromagnetic information from the magnet, which is in the back, has to chase the coil that is running away from it at 20% the speed of light.
Right.
So it is going to take longer for that field to reach the coil.
And the sources break down the math on this really clearly. Instead of the light taking the standard amount of time to cross that distance, it takes the distance divided by 0.8 times the speed of light.
So it's a visibly longer trip. But the reverse trip is totally different. The information from the coil in the front traveling back to the magnet has a much shorter trip.
Right, because the magnet is driving forward into that incoming signal at 20% the speed of light. They collide much faster.
Yeah. The text says that backward delay is the distance divided by 1.2 times the speed of light. The arrival times of the physical information are vastly asymmetric.
They are completely lopsided. The front receives information much later than the back receives it.
But then there is a glaring paradox here, isn't there?
Absolutely.
If the light takes longer to reach the front than the back, the physical reality is lopsided.
Right.
The coil is receiving a delayed, outdated version of the magnetic field compared to what the magnet is receiving from the coil.
Yes.
So here is where it gets really interesting. If the arrival times of the information are completely asymmetric, why doesn't the coil experience a voltage? Shouldn't it see a different magnetic reality?
You have hit the exact friction point the author is trying to expose here. It forces us to look at what the text calls the ultimate trick of nature.
The ultimate trick. I like that.
Yeah. The delay is fundamentally asymmetric, yes. But the movement at 20% the speed of light doesn't just change the timing of the signal.
Wait, it doesn't.
No, it actually physically alters the shape of the electromagnetic field itself.
Physically alters it how? Like the field is bending.
Think of a boat speeding through a calm lake. As it moves forward, the water waves bunch up tightly in front of the bow. They compress.
Oh, like a wake? Okay.
Exactly. Meanwhile, the waves trailing behind the boat stretch out and become longer. A moving magnet does the exact same thing to its magnetic field lines.
Really?
Yeah, this is a well-documented physical phenomenon linked to Leonard-Richter potentials.
Okay, that's a mouthful.
It is, but the concept is simple. Because the magnet is moving forward, its magnetic field compresses in the forward direction. It literally gets squeezed together, which makes the field stronger.
Wow.
And conversely, it stretches out and gets weaker in the backward direction.
So the magnet is acting like a snowplow for its own magnetic force.
Yes, that's exactly it. And here is where the universe covers its tracks.
Okay.
The physical distortion of that field, the bunching up of the waves, perfectly, mathematically offsets the asymmetrical time delay.
Wait, let me make sure I'm following this.
Sure.
The coil in the front is running away, so it receives the magnetic information later. It is experiencing a lag.
Right.
But because the magnet is moving forward, the field that finally reaches the coil is compressed and stronger.
Yes. The field is compressed by the exact mathematical proportion needed to cancel out the extra time it took to arrive.
That is insane.
It really is. And on the flip side, the magnet in the back receives the information from the coil sooner, but it receives a stretched, weaker field.
Okay.
So when you calculate the actual physical interaction using Maxwell's equations,
Yeah.
the laws that govern electromagnetism, the extra time delay and the physical field compression zero each other out entirely.
That is absolutely mind-bending. The universe just balances the ledger.
It does. This perfect cancellation is known as Lorentz covariance. And the author's core argument is that this physical cancellation is the real reason no voltage occurs in the coil.
Not some magical grid.
Exactly. It is not because the magnet and coil are sitting on a rigid, pre-existing spatial grid where everything is perfectly synced and universal now.
Right.
It is because the physical delays of light and the physical distortions of the moving fields perfectly hide themselves from the observer.
So bringing it back to the analogy, the video game engine is dynamically adjusting the strengths of the weapons to make up for the server ping, so the players never even realize they are lagging.
That's it exactly. It is a functional illusion.
It is a functional illusion that allows us to draw a grid and pretend the grid is real.
Yes.
To bring this abstract concept crashing back down to reality, the sources use a beautifully vivid illustration.
I love this part.
It contrasts two totally different ways of navigating the world. On one side, you have the math-brained physicist, and on the other, you have a navigator standing on the deck of a rolling ship in the middle of the ocean, using a sextant to measure the altitude of the star Sirius.
It is such a powerful analogy for distinguishing between a theoretical map and the messy local reality of observation.
Right. So the math-brained physicist sits in a quiet, stable room. They assume that perfect, rigid Cartesian grid.
Yeah, that imaginary upper layer.
Exactly. They look at their equations and declare, the star is located precisely here, the ship is located precisely there, and the angles form a perfect triangle.
Right.
It is an imaginary top-down view of reality. But the sailor out on the water, they're standing on a pitching deck. The ocean is violently throwing them up and down.
Yeah, they cannot rely on a rigid, absolute spatial grid because their physical reality is in constant chaotic motion.
Exactly. The sailor knows they have to bet their life entirely on local measurements. They hold their chronometer to check the local time. They hold their sextant to measure the angle of the star's light hitting their eye in that exact turbulent fraction of a second.
Right.
They have to infer their true position in the world, despite the fact that the light from Sirius took over 8 years to reach them, and despite the fact that their ship just dropped 10 feet in a swell.
The sailor is basically acting as their own information officer.
Exactly. They are taking raw, noisy, delayed data and calculating a contour map of reality just to figure out where they are.
And that is the author's piercing critique of modern science. The sources argue that somewhere along the line, theoretical physicists forgot they were standing on a rolling ship.
They got too comfortable.
Yeah, they fell so in love with the math that they started believing the perfect, flat, abstract map they drew was the actual ocean.
So what does this all mean for us? Like, if the flat map is an illusion, how do the sources suggest we actually map the universe?
Well, they argue that physics must incorporate local, delayed observation into the very foundation of its coordinate systems. Instead of an XYZ grid of space, they suggest leaning into what are called past light cone coordinates.
Meaning your position isn't defined by a fixed grid, but entirely by the sphere of delayed light signals crashing into you at any given moment.
Exactly. It makes reality entirely relational. Your now is just the intersection of countless pasts.
That's deep.
It is. And what is truly remarkable is that the AI models in the sources point out this is not just some isolated internet theory.
Wait, really?
Yeah, this framework perfectly aligns with the most cutting-edge frontiers of modern theoretical physics.
Like what?
The AI specifically brings up Carlo Rovelli's theory of relational quantum mechanics and the holographic principle.
Oh, wow. Those are massive foundational concepts in modern physics.
They are. And both of those theories suggest the exact same underlying truth. A fixed background spacetime grid does not exist.
It's all just connections.
Exactly. Spacetime is not an empty container that holds the universe. Spacetime is a secondary emergent property. It is built entirely from the network of local information exchanges.
Just like the information officer rendering the video game world from delayed server pings.
Yes. The universe constructs the illusion of spacetime out of the lag of quantum information.
Man, we have covered some incredibly deep foundational territory today.
We really have.
Let's recap for everyone. We started by exploring how Einstein's rigid space-time grid, that comforting assumption that you can map the universe perfectly in the present tense, might just be a mathematical ghost.
A pure fantasy.
Right. We traded that fantasy grid for a nested neural network, a universe made of information officers constantly back-calculating delayed light signals to render a shared reality.
Yep.
We saw how, even in a strict physics test with a moving magnet and coil, the universe physically compresses magnetic fields to perfectly mask the asymmetrical delay of light.
Which tricks us into believing the rigid grid is real.
Exactly. And we ended on a rolling ship, reminding us that we can never confuse the perfect mathematical map with the turbulent, delayed reality of the ocean.
Is the kind of paradigm shift that just forces you to reevaluate the basic mechanics of existing in the world.
Totally.
And, to build on that, there is a staggering implication here when you apply this model to human consciousness.
Oh, what do you mean?
Well, if the universe operates as a layered information processing system where now is just a compiled output of delayed signals, it completely reframes what your brain is doing every single second of the day.
Okay, I'm tracking.
When you look up at the stars in the night sky, you know you are looking back in time. But honestly, even when you just look across your living room, you are receiving delayed, raw data.
Because even over a few feet, light takes time to travel.
Exactly. Your brain, acting as the ultimate biological information officer, is frantically synthesizing those incoming light waves, back-calculating the tiny delays, and rendering a cohesive 3D room in real time.
Wow. So my brain is the game engine. The room I'm looking at isn't objective reality, it is the compiled output layer.
Exactly. Which leaves us with a massive question to ponder.
Lay it on me.
Are time and space actually fundamental forces of nature that exist out there in the cold void of the universe? Or are time and space just the user interface, like the desktop icons, that our minds and our mathematics use to make sense of the universe's ultimate limit on the speed of information?
Oh, man. That concept that the perfect map of reality is just a UI we project to handle server lag, that is going to stick with me for a long time.
It's a lot to chew on.
It really is. Thank you to everyone for taking this deep dive with us today. Keep questioning the perfect maps you are handed, and keep questioning the reality that is rendering right in front of your eyes.